in examples 5 through 7, we're going to choose the type of test to be used for a hypothesis test. So example 5 reads, a nutritionist wants to determine if more than, I'm going to underline the key information as we read this, if more than 65% of local residents eat vegetables daily, a random sample of 120 individuals is observed, what statistical test should be used? Because we're talking about a percentage, this is another way to say we're talking about proportion. So the only test that we have for proportions is z-test for proportions. So we just need to make sure that the conditions are met to be able to use a z-test. All right, so the conditions that we need to make sure are met is that n times p, that's the sample size, times the probability of success, is greater than or equal to 5. And the second condition is that n times q, which is the probability of failure, is greater than or equal to 5. So our sample size is 120. So if I take 120 times my probability of success, which is 0.65, when I multiply that together, I get 78, which is certainly greater than or equal to 5. Now when I check the condition n times q, I would have 120 times, now the probability of failure is going to be the complement of 65%, which is 35%. And when I multiply those together, I get 42, which also is greater than or equal to 5. So our conditions are met so that we can use the normal distribution to approximate the binomial distribution, so we can use this z-test for proportions. Now, to choose what tail we're looking at, because, let me highlight this, because it's asking or testing to see if it's more than 65%, then that means because we want to see if it's greater than, we're looking at the right tail. So this is going to be a right-tailed test. The tailed test relies on what exactly you're testing. If you're looking to see if it's more than, then you look to the right. If you're looking to see if it's less than, then you're looking at the left. If you're looking at whether or not it's just different and you don't care if it's more than or greater than, you just want to see if it's different, then you're looking at both tails, which is why we have two-tailed test. Okay, example 6 says, a manufacturer wants to assess whether the average lifespan of their new battery is different from the expected lifespan of 500 hours. They collect a lifespan data for 30 batteries, and we know the population standard deviation. What statistical test should be used? Now, the key word here is that we're talking about averages. So we're going to narrow this down to either a t-test or a z-test. I'm going to say that we are going to use a z-test here because we are given that we know the population standard deviation, and that's one of the conditions for the z-test. The conditions to use the z-test is that you have to know the population standard deviation, which we do. And the second condition is that or statement where you just have to satisfy one of them, that the population distribution is approximately normal, or the sample size has to be greater than or equal to 30. Now, it doesn't tell us in here that the population distribution is approximately normal. So we need to check to see if the other condition is met, which is that the sample size is greater than or equal to 30, and it is, right? We're using a sample of 30, so this condition is met. Okay, so we definitely can use the z-test. Now, if we look at what we're testing, we're looking to see if it's different from the expected lifespan of 500 hours. Because we're saying that it's different, we're looking to see if it's either greater than or less than. We don't care which one, we just want to see if it's different. So this is going to be a two-tailed test. All right, example 7, a university wants to determine if the average GPA of its students is significantly less than the national average GPA of 3.2. They collect data of 24 students. Assume the distribution of the GPAs is approximately normal. Which statistical test should be used? Now, we're talking about averages here, so we're going to use z-test or t-test. Now, because we're not given the population standard deviation, I'm going to say that I think we need to use a t-test and the student t-distribution. Oh, I forgot up here to state that in example 6, let me add it in there. This should be the normal distribution that we're using. All right, now the conditions is that sigma is unknown. And then the second condition is that the population distribution is approximately normal. Or the sample size is big enough. This one is met, condition 1, because we don't know what the population standard deviation is. It's not given to us in the question. However, if we look at the second condition, if you notice our sample size is only 24. So the condition that the sample size has got to be greater than or equal to 30 is not met. So we need to make sure somewhere in the question that we read that the population distribution is approximately normal, and we're given that here. So we can definitely use a t-test. We check to make sure it met all the conditions. We're using the student t-distribution, and because if you look at this, we want to check to see if it's less than the national average of 3.2. Because of less than, we're going to use a left-tailed test.